Today we're going to be talking about the tissue level of organization. Now remember, tissues make up organs and tissues are made up of cells. So we're going to see the foundational basic structure of tissues in the body and discuss the different classifications. Okay, first of all, we have a chart here that really lays out the four major categories of tissues in the body. We're going to start out with the epithelial, work our way through. We'll do them a little bit out of order as they are on this chart, but we will cover all of these. Now, if you'll notice that we have tissues at the top left, and then we actually have the four types of tissues that we have in the body. Starting with the left, we have the epithelial tissue, which we'll be starting out talking about. We have muscular tissue or muscle tissue. We have nervous tissue, and then finally connective tissue. So let's go ahead and begin with the epithelial tissue and start using this chart. We'll use this chart each time we cover one of the four major tissues. When we talk about epithelial tissue, then we're going to first of all discuss, well, how is it different from other tissues? What are its characteristics and what are its functions? And so the characteristics of epithelial tissue is the fact that these are going to be groups of cells that are going to have a free end to them on one side of the cells. In other words, they're going to line something, so one side of the cell that lines something has to have a free end. The other end of the cell is going to have a basement membrane which connects the epithelial tissues to other types of tissues. Especially we see them connecting to some of the connective tissues. We know that epithelial tissues are actually avascular. They don't have blood vessels running directly into them. And we know that the epithelial tissues basically divide by mitosis. Now, the function of epithelial tissues, they tend to either be membranes, and again, therefore they are lining things and protecting things, or they are glandular tissues. So the glands in our body are primarily made out of epithelial tissue, and therefore they secrete, they absorb, and they excrete different materials. Now, when we're looking at epithelial tissues, knowing that they're broken into cells, then we can actually name them by their classification and their arrangement. So we're going to be discussing this and looking at some of the criteria for this. Notice that under classification, we have the basic shapes of the cells themselves, which are either going to be flat or squamous. They're going to be cube-shaped, about as wide as they are tall, or they're going to be column-shaped, where they're much taller than they are wide. And then we're going to notice their arrangement. They're either going to be one cell layer thick, which we call simple, or they're going to be more than one cell layer thick, which we're going to call stratified, or they're going to appear to be stratified when they are truly just simple. We're going to call those pseudo-stratified. Okay, let's look at an example of some epithelial tissue, and let's look at an example of this picture. What we see here is we see simple squamous epithelium. So what that means, since it says it's simple, it means that it's only one cell layer thick, and notice that the cell would have a free end that would not be in contact with anything that would cause it to be able to line something. The other end was going to have a basement membrane, which we can also call a basal lamina, which will connect this group of cells to some sort of other tissue, such as connective tissue. In this case, it's simple, so it's one cell layer thick. It's squamous, meaning that the cells themselves are flattened. In other words, their height isn't near as tall as their width, so they're fairly flat cells. Now, we're going to see these type of cells in places where we need very thin surfaces, particularly where we're going to exchange things across the surface of the cells. So it's going to reduce friction. It's going to allow things to go through them, such as gases or fluids, and it's going to be able to perform more absorptive or secretion activities. Next, we see the stratified squamous, and in this case, the stratified means that there's more than one cell layer thick. Now, notice the top layer of cells has the free end, something that's not attached, and then the rest of the cells under it, the bottom layer is actually going to be, again, attached to a basement membrane or basal lamina, which attaches it to other tissues such as connective tissue. In this situation also, not all the cells are actually squamous, but really in a real situation, the majority of the cells, especially the upper layers, the more superficial layers, there's actually many more of them that are flattened out in this situation than the ones that are actually next to the basement membrane, which in this case would be cells that are going through continual replication or continual cell division, and that's why these are called stem cells. But in this situation, again, what we see is we see several layers of cells, therefore they're stratified. We see the several top layers are flattened out, so we call these stratified squamous. Again, we're going to see these in places where we need more protection. Again, they're going to line things such as our mouth, throat, esophagus, and so on. But it's going to be in places where we need more than just one cell layer thick, so something doesn't just rub off the layer. And also, it can be in places where possibly we shed the top layers but keep replacing them with our stem cells. Okay, next we see a situation where we actually have simple cuboidal cells. So again, simple meaning that there's only one cell layer thick, so they'll have a free end. The other end of the cell will be connected to connective tissues that will then be connected by the basal lamina or the basement membrane. And we see the shape of the cell here is kind of cube-shaped. It's not flat. It's not real long. It's basically cube. So we're going to find this in several places in the body, and we'll talk more about the actual places in the body as we get to them, but let's learn to recognize, first of all, what's epithelial, what is simple, and then what are the basic shapes, and what is stratified. Here we see something really fairly rare in the body. We see stratified cuboidal epithelium, and of course, again, the free end is going to actually be around the space, which would be called the lumen. In this case, the space where the sweat would be in the sweat, because this is actually what makes up a sweat gland duct. So the tissues that make that up are the stratified cuboidal epithelium, which are made up of the cells. And since it's stratified, we know that it's more than one cell layer thick. We know that at least one of the layers has to have a free end. In this case, the free end is next to the space called the lumen. And then we see that the other ends are actually going to have a basement membrane, which is going to connect the rest of the cells to the connective tissue, which is holding the structure together. Again, this is relatively rare in the body. Stratified cuboidal, stratified columnar are rare, and they're going to be where we need more protection, and we're going protection and also where things are secreted or absorbed. Okay, here's a unique situation also. This is called transitional epithelium, and in transitional epithelium, what we have is we have cells that have the ability to stretch. Therefore, they change their shape. Now, something like the urinary bladder, as it fills up with urine, would have the ability for the cells to stretch as it fills up with the urine. And so, notice in the picture on your left-hand side, we see the empty bladder. We see the taller cells. Then if you look over on the right lower section of the picture where we see the full bladder, notice how the cells have transitioned from one shape to another. So transitional epithelium does allow stretching, which will change the shape of the cells. In this picture we see an example of simple columnar epithelium. Simple again because it's one cell layer thick. Columnar because the shape of the cells are much taller than they are wide. In this situation we also see something interesting that we see a lot in the body, and this the fact that we see on the free end we actually see microvilli, which are several folds in the upper portion of the cell. Now when the body folds something, it does it so it can have increased surface area for a smaller amount of space. I'll be mentioning that quite often and reminding you of that phenomenon. And so we see that particularly in cells where we need to have greater absorptive ability, but maybe we don't have a lot of space for that absorptive ability to fit in. Again, looking at this, we see that we have the basal lamina, also called the basement membrane, that's connecting these cells to the connective tissue. A lot of times the connective tissue will be something called areolar tissue. We'll talk about what that means a little bit later. Now, we see these type of cells usually in areas that have a lot of friction, so they need to be thick to keep that friction from just breaking down the cells. And also in these areas where we have quite a bit of cell activity as far as things either being absorbed into the cell or secreted from the cell, or even both in certain situations. Well, particularly these cell shapes will really come into great usage next semester when we talk both about the kidney and what's going on in areas called the nephrons, and when we talk about the digestive system, they'll become very, very important. But right now it's just time to learn the types of tissues and how to identify them. Okay, something else that we see here is a term called pseudostratified. In this case, these are something similar to the microvilli epithelial, and what cilia does basically is it usually moves, it usually absorbs some sort of mucus, and then it traps things, and the cilia sweeps the things away from the cells. Now in this case though, the pseudostratified columnar epithelium, pseudo means it's falsely stratified, so just by glancing at it, it may appear as though there's more than one cell layer thick, but in reality, we have cells that are overlapping each other, giving the false impression that they are stratified. But if we followed every cell down and we kind of pulled the layers apart, we would see that every one of them attached to the basement membrane. Okay, again, another one of our fairly rare types of epithelium, which is the stratified columnar. But again, stratified being more than one cell layer, columnar being cells that are much taller than they are wide. Again, anytime we're talking about epithelial, at some point in the tissue, there's a free end that is lining something nothing's attached to, and then there's another end with the basement membrane, again called the basal lamina. Notice in all these we haven't seen any blood vessels running into these, because that's another characteristic of these type tissues. They are avascular, meaning that blood does not run in them, blood vessels do not run in them. It may run right up next to them, right up next to the basement membrane. They still may get the contents that's coming from the blood, but as far as the cells themselves, they don't have blood vessels running in them. Okay, so we said that epithelial tissue makes up both membranes and glands. And among glands, there are different types of secretions that certain glands or certain cells in the glands will produce. So what we want to do is look at three categories of secretions coming from three different glands in this picture. Starting at the top, we notice that we see something called a merocrine gland. Now, if you look at the picture of the cells, the merocrine gland being an example of a type of secretion that a salivary gland would produce. If we look at the cells up in the right-hand corner of the picture,